Hello guys, so in this lecture we'll see delays in computer network. Okay guys, so let us begin with the delays in computer networks. In CN, computer network, so we'll see various delays are there in computer network. So we'll see one by one. First one is known as that is transmission delay. Transmission delay or transmission time. Let's say one host is there or sender is there, isn't it? And let's say this is the link. This is the sender, and here let's say one receiver is there, isn't it? And let's say sender wants to send this much data to the receiver R, isn't it? Now, what is transmission delay? We can say that the time taken, we can say that the time taken to transmit this particular data packet onto the link is known as what? Transmission delay or TT, transmission time, isn't it? So the time taken to transmit this particular data packet is known as transmission delay. Remember guys, this is the transmission means not that this particular data is received by the receiver. Ultimately, we can say that transmission delay means time taken to put this particular data over the link, isn't it? So this particular data packet is, we can say that, placed over the link. That time is known as, or that delay is known as transmission delay, isn't it? So now this is not the formal definition. For formal definition, you can follow the definition in the standard book. This is the informal definition. So we can say that the time taken to put or place the data over the outgoing link, isn't it? That is known as transmission, isn't it? Or transmission delay. Now let us consider one example. Let's say bandwidth of the link is given to you. That is the bandwidth of the link is given as that is 2 bits per second. And let's say data packet size is given to you, that is 20 bits. 20 bits is given to you, isn't it? Now you only tell me, yes, we can say that because this is the bandwidth, so we can conclude from here. So we can say that from this bandwidth, we can conclude that in 1 second, 2 bits of data can be transmitted. So in how much time 20 bits of data get transmitted? That will be 1 upon 2 into 20 seconds. So we can say that that will be the 10 seconds, isn't it? So that will be the transmission time. So ultimately we can say that the formula for transmission time will be the L by B, where we can say that L is the length of the data packet, where B is the bandwidth, isn't it? I hope this one is clear to everyone. So we can say that yes, TT will be the L by B, where L is the length of the data packet and B is the bandwidth of the link, isn't it? So that is the transmission time. Now we can say that this data is not transmitted till now, yes, or not received at the receiver end. This is transmitted. Transmitted means only we can say that this data is put over the outgoing link, isn't it? That delay is known as transmission delay, isn't it? Okay, whenever the data get reached, when we can say that this last bit get arrived to the receiver, then only we can say that this data will be reached, isn't it? So in the entire transmission, we can say that this transmission time is the time to put the data over the outgoing, isn't it? So let us take some examples. Let's say length of the data packet is given to you, that is 2000 bits, and bandwidth of the link is given, that is 2 kbps, isn't it? Now question is, what is transmission time? So you know transmission time is the length of the data packet divided by bandwidth. So length is 2000 bits and bandwidth is 2 kbps, so 2 into 10 raised to power 3 bits per second. So yes, we can say that this one will be what? Yes, we can say that that is 1 second, isn't it? So transmission time will be the 1 second. Now let us consider one more example. Let's say here also, let's say length of the data packet is given as 1 kilobits and bandwidth is given to you 1 kbps. Now what will be the transmission time? That will be the length divided by the bandwidth. Now you only tell me whether here also answer will be 1 second or not. No. Why? Because for data we can say that if kilo is the given, that means what? 1024. That is 2 raised to power 20. And for bandwidth, it will be the 10 raised to power 3. Isn't it? So bits per second, this is bits. So ultimately answer will be 1.024 second. So be careful because data is measured in terms of bits. That's why we can say that kilo means 2 raised to power 10. Where bandwidth, in bandwidth we can say that these are measured in terms of frequency, and in the frequency we can say that kilo means 10 raised to power 3, isn't it? So be careful. So we can say that in the next slide, let's say whenever data is given to you and bandwidth is given to you. So remember in data k means 1024, that is 2 raised to power 10, isn't it? Mega means what? 2 raised to power 20, that is 1024 into 1024. Similarly, giga means what? We can say that 1024 into 1024 into 1024, that is what? That is 2 raised to power 30. Whereas whenever bandwidth is given, then kilo means 10 raised to power 6. Mega means we can say that, sorry, kilo means 10 raised to power 3. Mega means 10 raised to power 6 and giga means 10 raised to power 9 and so on. Isn't it? So be careful, isn't it? Okay. Next one, let us consider. Let's say this is sender and this is a receiver. So let's say sender having this particular data. So I already told you guys that the time taken to place this particular data over the link is known as what? PT. But you see at this particular time this data is not reached as at the receiver. So yes, this particular data packet have to travel this particular link or this particular distance, isn't it, to reach at the receiver, isn't it? So yes, we can say that this data get received. That means the last bit we can say that this particular bit must reached at this particular point. So this delay we can say that, or this particular time is known as what? Propagation time. That is known as PT. Propagation time, PT, isn't it? So you can see this propagation delay or propagation time. This depends on what? The distance of this particular link, as well as we can say that the velocity of the signal inside this particular channel, isn't it? So here propagation time or propagation delay will be what? That will be the distance upon velocity. Distance upon velocity. So we can say that in general in fibers, optical fibers we can say that the speed of the signal is 70% of the speed of the light. So we can say that here velocity will be what? 70% means 0.7 of speed of light, that is 3 into 10 raised to power 8 meter per second. So that will be 2.1 into 10 raised to power 8 meter per second, isn't it? So you need not to be by heart this particular velocity and all. Everything will be mentioned in the question statement. isn't it? So let us consider one example. Let's say, yes, let's say distance of the link is given to you 2.1 kilometer, and velocity of the signal inside the channel is given to you 2.1 into 10 raised to power 8 meter per second. And question is, what is the propagation till time or propagation delay? So you know propagation time is what? That is distance upon velocity. That will be 2.1 into 10 raised to power 3 meter divided by 2.1 into 10 raised to power 8 meter per second. So this is going to be 10 raised to power minus 5 seconds, and this can be written like that: 10 into 10 raised to power minus 6 seconds. So that is what? That is 10 microseconds, isn't it? Okay. So I hope this one is clear to everyone, isn't it? Now next one, let's say, just consider, let's say this is sender and this one is a receiver. So here, as soon as we can say that any packet is received at the receiving end, then we can say that immediately it is not processed. Why? Because we can say that it will depend on the speed of the processor. So we can say that one queue will be there. First the packet will be placed inside that particular queue, isn't it? So we can say that when the receiver will process at that particular time, yes, we can say that when one packet is processed, then there will be a turn for second one and so on, isn't it? So we can say that some delay will be there, and that delay will be what? Queuing delay, isn't it? So immediately we can say that immediately the packet will not be processed, isn't it? So there will be a buffer. Buffer means we can say that a temporary storage, isn't it? So initially this particular data packet will be placed in a queue inside a buffer, isn't it? So some delay will be there, isn't it? So that delay is known as what? Queuing delay, isn't it? Let's say queuing delay of this particular packet get over, and receiver will pick this particular packet and process it. So the time taken, we can say that the time required to process any packet, that is known as what? Processing delay, isn't it? So two more delays are also there, that is queuing delay and processing delay. So there is a difference. Queuing delay means we can say that the delay inside the buffer, and once that delay queuing delay get over, then that particular packet will be picked by the receiver, and receiver will process it. So while processing, the time taken is known as, we can say that, processing delay, isn't it? So we can say that there are four kinds of delay, that is transmission delay, then propagation delay, then we can say that queuing delay, then we can say that processing delay, isn't it? So we can say that there is no formula to calculate queuing delay as well as processing delay. So we will assume these delays as equals to 0 in the program, isn't it? Why? Because processing delay depends on the type of the processor at the receiving end, isn't it? Whether it is fast or slow. If we can say that if the processor at receiver end is slow, then delay will be, processing delay will be more. And if the speed is high, processor speed is high, then the processing delay will be less, isn't it? Okay. So I hope this one is clear to everyone, isn't it? So these are the delays in computer net. I hope this one is clear to everyone. Okay, guys. So thank you so much.